So good evening students. Now let us start off with the sample paper, CBSE sample paper 2019-20. So according to the this is an opinion given by you. When I've posted a question in the community tab, you said you wanted the sample paper. I've asked how many of you is the sample paper, solving sample paper would be interesting, or how many of you is it useful? So almost maximum of 95% said yes. So let us start off. Solving the sample papers according to the CBSE grade 12 new pattern. Right. So before starting solving the sample paper, as I told you, I'll be starting the series. Means I've picked up sample papers which are posted or introduced by the Super 20 series by Full Circle Education. This is the first page. In Full Circle Education Private Limited, this is the sample book which I have received. Right. What is the reason I have picked up this book? Let me explain. When I've gone through each and every sample paper of this, point number 1, the concepts or the pattern of the question paper was exactly the same according to what CBSE has released. Point number 2, the questions which they have picked up, everything is very relevant. They have given 10 solved sample papers and 10 unsolved sample papers. Right. So they have picked up each and every question perfectly according to the concept, very nicely given and explained. So I'll be solving from this. Apart from this, I'll also be solving most of the sample papers which will have different questions. Right, students? Yes. So before starting with the first topic, as you know, the next upcoming year, CBSE grade 12 chemistry paper as a pattern change, this is how is the bifurcation. So I have already done a video for this stating how many marks, which one would be there, what is the advantage, what is the disadvantage, everything I have discussed in the previous video, how to go or how to study CBSE grade 12 chemistry. Right. Now before starting the first section A, we very well know how many sections are there in the paper. We have section A, section B, section C and section D. Now see the bifurcation of questions which they have given. Here they have given 1 to 20 question. 20 means 1 to question number 1 to question number 20 are all 1 mark questions. It will be objective based. It can be either match the following sort of questions, or it can be one line answers, or it can be MCQ questions. Right. Means the first one would be the paragraph question. First question in section A. Based on the paragraph, they'll be giving you 5 questions. After that, we'll be going to one line answer questions. After that, we'll be going to MCQ questions. All these 3 varieties will come under question number 1 to 20, which is objective type. After that, from question number 21 to 27 are all 2 marks questions. Right, students? So 2 marks questions are short answers where you will be writing only 2 lines maximum of that. After that, from 28 to 34, we have 3 marks questions where it comes in the category of long answers. Some of the questions may have numericals, some will have 1, 2, 3 subtopics in that. Right. After it comes to 35 to 37, you have a 5 mark question. Right. The 35th question, 36th and 37th is a 5 mark question. Altogether it comes to 70 marks. Right. So as I told you, I'll be picking up from this series. Let us start off first with this. So let us come back and start the first question, that is from section A, the paragraph based question. I'll be doing that. Then I'll be going to 1 mark questions. Then I'll be doing MCQ questions. Then I'll go to assertion and reasoning type questions also. Right. Let's start. Right, students. Now let us come back and start solving the question paper or the sample question paper for your next academic year, the most important in the new series. Right. So for the first question, as I told you, in section A, that is from 1 to 20 are all objective type, which is going to include your paragraph based questions. Next, it will include your 1 mark questions. It will include your multiple choice questions as well as assertion and reasoning type questions. So when I have to take the first sample paper, the first question, let us read the question and let's see how to answer in the exam. So what do they give us? The statement, let us read this. Read the given passage and answer the questions 1 to 5 that follow. That means 5 questions are going to repeat. Right. So let us read the paragraph first. So first important thing here, all the noble gases have a stable electronic configuration of NS2 NP6 except helium, which has 1s2 configuration. That's a known concept of noble gases. Right. Thus these elements have no tendency either to lose, gain or share electrons with the atoms of other elements. Obviously we very well know noble gas elements are inert. They have completely filled duplet configuration or octet configuration, so they're not going to either gain or lose or share electrons. That's perfect. Then their combining capacity or valency is 0. Correct. If they don't gain, if they don't share, the valency will obviously be 0, isn't it? Right. Now, thus they have high ionization energy accepted and large positive value of electron gain enthalpy. What is this? Electron gain enthalpy. That's also okay. Now, based on this paragraph, the clues which they have given us, they have asked us 5 questions. Let's see the first question. What is the first question? Why do noble gases have very low boiling point? Right. So whenever we speak about, or in the exam when they give you the concept of boiling point, first thing what you should remember when boiling point question is given, first concept or your mind should directly go into the concept of what is the type of force acting between the atoms, right? Because when suppose this is there, if there is a sort of bonding, ionic bonding is there in this. Suppose there is a sort of van der Waals force of attraction is there in this. Suppose if this is the sort of dipole forces are there in that, then what happens every time? The force of attraction depends upon the type of bond is between them. So based on the type of the bond, I can easily break it, or I can easily, the bond either would be strong or very weak. Let's see. So whenever there is a low boiling point concept, you should just strike the first. What are the different types of bonds we have? We have hydrogen bonding. Okay, hydrogen bonding is one concept, right? After that, what is the next type of bonding which we have? We have ionic bonding. That also we'll write ionic bonding. What is the next type of bonding we have? We have ion dipole forces, we speak about ion dipole or ion forces, isn't it? Ion dipole forces are there. Then again we have ion that particular dispersed force which is there, that is also there, right? After that, one more force of attraction which we call it as van der Waals force of attraction, the weakest force, or the London dispersion forces also. So this is D, let me write properly, right? So next one would be London dispersion forces, London dispersion forces, or it is nothing but van der Waals force of attraction, van der Waals force of attraction, right? So now when I have to speak among the bonding, this is the strongest one, this is the weakest one. Now as we told here, they've asked why is the boiling point very low? A simple concept. Take your pen, write answer. You need to first important keyword you need to start. As noble gases, we very well know the completely filled. The valency is 0. Start your answer like this. Boiling point and forces of attraction are first directly linked. Let us write that. Boiling point and force of attraction. Let me draw one line here. Attraction are directly related, correct? No? How are they directly related? Done. So as I said, if the force of attraction is weaker, I can easily break the bond, correct? If I can easily break the bond, easily the particular atom can participate in the chemical reaction. Yes. So here when I speak about inert gases, there what is the type of force? The force which is acting is van der Waals forces of attraction. So because of van der Waals forces of attraction existing in helium atom or in inert gas elements, the boiling point is very low. With less energy only I can break it, but participation wise it will not, because it is completely filled, right? So the same question, so you need to write van der Waals forces of attraction are present force of attraction are present in noble gases, hence low boiling point. This is done, students. I'm going very slowly for one question. I'm explaining 5 minutes. Note it carefully. So always remember, this is the keyword which you should start, and then this is the conclusion which you have given. Compulsory, you will be getting 1 mark in this. Let's come back and see the second question. Right. Now let's see the next question. What did they ask us? Why do noble gases have comparatively large atomic size? So boiling point is over. The next factor, atomic size. So whenever we speak about atomic size, one concept which I have to remember, what is that? Whenever a particular thing, or when we move from left to right in the periodic table, we very well know as we add atom, so the electron to the same subshell, the size decreases, correct? One more concept which you can write is from left to right in the periodic table, accepted, but helium, when it goes to inert gases, size increases. That is the thing. One word, as I can, if I have to write, I'll write only one word. First important thing, stable configuration. Okay, this is one. Now what is the stable configuration? Stable configuration of inert gas elements. Okay, now if stable configuration is there, what logic am I going to relate? If there is stable configuration, what will happen to the repulsion? There will be repulsion between the this one, right? The like electrons, means electrons will be there. Lot will be filled, outermost shell will be filled with more number of electrons, stable configuration. So because of the stable configuration and the electrons presence of more number of electrons, I will say like attract like. When like attract like, what will happen? Repulsion increases. Repulsion increases. When repulsion increases, what will happen to the atomic size? Atomic size increases. So this is the easiest way to write. But here in the sample book, what they get, they basically picked up, or they've explained the concept in terms of van der Waals radii and covalent radii. So I feel this concept also is perfect. They just gave the atomic radii of noble gas elements because of the van der Waals radius, as we have discussed in the earlier question, are considered means they possess van der Waals radii, while covalent radii is considered in case of other elements. So they said van der Waals radius is there in case of noble gas elements and covalent radii in case of other elements. So we always know van der Waals radius is larger than the covalent radii. So in that way also they have justified. One more reason for you all, simple, remember the noble gases have van der Waals radii, correct, and the other element have covalent radii. So van der Waals radii is always greater than covalent radius. That is the concept. So note here, where van der Waals radius is observed in noble gas elements. This is also very clearly explained, and covalent radii is present in all other elements. Done, students? This also is clear. Now 2 questions are over. Let us come back and read the third question. Right, when I come back to the third question, let's read that. What did they give? Why are the elements of group 18 called noble gases? So basically, when I have to speak about noble gases, so one thing you have to remember, noble gases or noble elements. What are the noble elements? We have gold and platinum, something analogy to that. So if I have to speak about inert gases or noble, first concept which I have to remember, or the key word is, first thing is they are stable configuration. That is what is important. So when I have to speak, okay, let us write that. They have stable and inert configuration. Inert means they are not going to participate in any chemical reaction because they are completely filled or stable, right? And because of the stable configuration, what will happen to the chemical reactivity? Yes, so because they are stable, chemical reactivity is very low, correct, students? Because they don't break up, chemical reactivity is low, right? And when I have to speak about one more concept, when what is the most electronegative element? Fluorine, chlorine, isn't it? So these particular things, they also react with fluorine and chlorine, and there are certain compounds of xenon which combines with oxygen also, XCO2, XCO3, XCO2F2, like that they'll be reacting with the most electronegative element. So that is also one more concept for knowing, means for them to be known as noble gases. They react with fluorine, chlorine, the most electronegative elements. So these 3 reasons made them, or we call them as noble gases or inert gas elements or zero group elements, because their valency is 0. right? Now let's come back and see the fourth and fifth question. So with this, all the 5 questions will be over, right? So which noble gas is used in filling balloons for meteorological observation? So we very well know, when we see this is normal hydrogen balloons we see, we also have the lightest one, that is nothing but the noble gas which we fill is nothing but helium. Remember, this is simple question, nothing too much logic in that. Yes. So let us come back and see the fifth question. What do they give us? Explain why no chemical compound is chemical compound of helium is known. Okay. See, we very well know in inert gases, xenon reacts. Yes, we have a compound with xenon. As just now I have told you different compounds of xenon. They react with oxygen and fluorine, right? To some extent, platinum also we have taken as an example in that inert gas in grade 12 textbook, right? So here helium, why no chemical compound of helium is known? What is the main thing? Whenever or if I have to form a chemical compound, at 2 atoms combining together form a compound, I require certain amount of bond dissociation. Means I have to break the bond, then form a new compound, correct? So if I have to speak about the helium, in the question they said why no compound is known, right? So when I have to break or take out one electron from helium, which is duplet configuration, 1s2, isn't it? So I require what is the name given to that? The amount of energy required to remove outermost electron from the valence shell is nothing but ionization energy. That is the concept. When they say no compound is formed, first thing you need to write is highly stable. Which stable? Highly stable with which configuration? With duplet configuration, means with duplet. Duplet means how many electrons? Duplet is nothing but 2 electrons, isn't it? Helium, right? So duplet. Now because of this high stable configuration, how much energy should I apply? I have to apply more amount of ionization energy. So the ionization energy, high ionization energy, done. Now how much is ionization energy? Basically the ionization energy of helium is almost 2370 kilojoules per mole. 2370. If I have to speak about neon, it is almost 2018 kilojoules per mole, plus or minus, I'm telling you. So I have to apply 2370 kilojoules per mole to break it and then form a bond. It is highly impossible, right? So because of this, helium ion or helium atom does not form more number of compounds. So this is your paragraph based question, students. I'm going slowly and again I'm telling. First paragraph based question, fifth 5 questions. First question was what it is about. Atomic boiling point. Why is it very low, they said. Then they've asked about atomic size. Then they have asked us about simple atomic size they've asked. After that, what is why the name of noble gas is given to them, they've asked. Then they've asked what is the gas filled. Then they've asked why it is not forming compound. That means whenever you're learning a topic, you need to learn the complete concept so that whatever question is given to you, you will be able to answer.